Hello everyone, this is Amir from Audio Science Review. Some of you have seen my previous video on this PS Audio PowerPlant P12 or 12. I did a bunch of tests on it, and I thought I was done with that. Basically, I showed that while it does regenerate AC and cleaner AC than my mains, although it does generate some extra noise in low frequencies, showed every which way that it made no impact on the output of either power supplies or the output of a real audio device. I thought I was finished with that, but then people inside the forum started to push for more testing. Specifically, they wanted to know how it performed under power. PS Audio advertises this very low output impedance. Just briefly, output impedance is the internal resistance that the device itself has, and as you pull current, that resistance can dissipate power, and with it actually lose regulation and some losses. So PS Audio advertises pretty low output impedance, near zero, basically 0.008 ohm, and people have taken that and said, well, that increases the dynamic power because surely that's better than your AC mains. And the company implies that in their marketing material just the same. So even though I had packed the unit completely and it was ready to be shipped back to its owner, I thought, oh, shoot, I better do this or it will hang around for a long time. So I went ahead and unpacked this 50-pound monster. It looks small, but it's so heavy. I lugged it back upstairs where my lab is and aimed to retest it. The new test was to use this linear amplifier class AB, although this one is what is called class G, and called Outlaw 2220. It's a monoblock single-channel amplifier. And these amplifiers tend to show more peak power than average power because they use unregulated output rails, output supplies. And I thought for sure, well, sorry, I'm getting ahead of myself. Let me show you first what happened was that with using just the raw AC power at that moment where I'm going to test P12, because as I said, they are voltage sensitive. So I run this test, and there's two tests in here. It's part of every amplifier test I run. And one is a continuous sine wave that is fed to the unit. And the analyzer, I give it a range of input voltages, and it will step between these things, either producing too little power for the distortion 1% that I'm aiming at, or too much distortion, and it will try to keep adjusting the output power of the amplifier until it hits this 1% THD distortion. And whatever that number winds up being, then it spits out the power. So it's an iterative test. It's basically pushing the amplifier to at different power levels. And then the second test is a true burst one. So this is a continuous power, but at 1% distortion. This one is a burst rate where it's 20 cycles of 1 kilohertz that is the same as the one on the left. But for 480 cycles, or vast majority of the time, it's at much lower level. The idea is that it's sort of simulating what music would be, where it's at low level and all of a sudden you get a peak. And and then it does the same thing that it does for this one on the left to compute the power. It's actually a CE standard called 2006-490A. It was made for car amplifier guys. Car amplifier guys, as you probably know, if you've been in that domain, they want to advertise big numbers always, and they usually cheat and put out ridiculous numbers. This was a way to get them to all cheat the same way. And at any rate, I use it to show the dynamic power beyond sort of continuous power. And indeed, we see that this amplifier puts out tons more power when you just excite it for a short period. That's because it's got internal capacitors in the power supply that are able to supply that power. But if you keep the amplifier going, then they get depleted and power, the voltage droops and the power with it goes down. So we have, I don't know, 70, 80% more power when we do this. So this is an ideal candidate for any device that claims to improve dynamic power, as this PS Audio PowerPlant P12 claims that on this thing. So I then took the routed the AC instead of being directly from the wall, which is what these results are, and routed it through P12. I actually used an aftermarket outlet. I'll show you. I mean, sorry, cable, power cable. It's a $200 power cable from a company called Pangea. It looks very high end and has all the trimmings of high end power cables, but the price is not outrageous. So if you're really insisting on getting fancy power cords, I recommend getting the Pangea stuff, and it comes in different lengths and different prices on this thing. But I've had it since 2017. I never get a chance to test it. I don't use it for anything except for these special occasions. Anyway, back to our comparison, and let me reduce this in size so we can see both of these together. So when I run this exact same test, but this one routed through the PS Audio P12 power regenerator, we see that we drop in power from 371 watts. We drop down to 340 watts, about almost 8% power loss. This is in the continuous. And then in the burst power, which you would think is where the company is advertising it'll improve things, it also dropped 8% almost. We lost about 50 watts or 45 watts between these two instances. So this is a real live test. It's the latest amplifier I had that was sent to me for measurement. I didn't pick it out of anything special. I didn't know what the results were going to be. I let the measurements speak, and the measurements are saying, no, this is not doing what you think it's going to do. I ran a different test then. So, all right, the power loss is a power loss, but let's see if it reduced noise and distortion. And this is, again, a standard test that I run. It's a sweep where the input of the amplifier is gradually increased, and the analyzer measures THD plus N, which is harmonic distortion plus noise. Let me enlarge this again so that we can see it better. It's into a 4-ohm load. And in green, it's again, we're just plugging into my power strip that I use for everything. And it produced 313 watts. And you can see the dot over here where I finished grabbing the power. And when I plug it into P12, though, notice that the same thing happened as before. Now we lost power, almost 10% of our power, down to 283 watts. They're kind of close in here, but there's a log display in here, so a little bit of distance here translates to a lot of power. So we lost power in here, and that's not good. This is basically a third way of measuring power, and we didn't get there. But importantly, look at how the two graphs, with or without PS Audio P12, they land exactly on top of each other. The part of the curve that slopes down in these amplifier power tests is completely dominated by noise, meaning that as we get more power, the noise becomes a smaller and smaller ratio of it. So this graph improves performance, even though nothing's improved. We're just getting louder and louder signal relative to a constant noise level. And we see that the noise has not changed, because if the noise had changed with P12, the graph would have come down here, lower, somewhere here, and it did not. It sits identically to the raw AC power. And then when the graph changes its slope from being that straight line to either horizontal or it goes up, it means distortion is now the dominant factor. And we see that when distortion is dominant factor, nothing was improved with P12 either. So in both cases, we either see no improvement in fidelity, and we have a power loss. So the question is why? One would think of, intuitively you thought you'd get more power, but conservatively you would say same power, but we're actually losing power, losing performance. And clearly the company doesn't tell you anything about losing performance. So I showed you the impedance that the company advertises, 0.008. So I said, well, let's measure that. To measure that AC, especially under load, and it's high voltage, it's not a trivial exercise, and the kind of setup you need is very complex. And of course, PS Audio never tells us how they measured their impedance either. It just says that's the number, take our word for it. It's like, yeah, sure. Tell me how you measured it, whether you just computed it on paper, or did you just probe the inside of the amp and didn't go probe it out on the outside across outlets and everything. But anyway, I happen to have all these little cool tools, and one of the things I have is this little analyzer is designed for electrical line compliance testing and safety testing. It's by a company called Ideal that makes a lot of these things. It's portable. You walk up to a industrial setting and you can just instantly plug this in. You get the voltage and you can change the safety of the wiring, the impedance, and you can see if they're compliant with code and what have you. It's pretty good. It's $500 almost, so it's not a cheap little, actually $400, sorry. Fish story, the cost of the instrumentation. But anyway, it's a nifty little device. It's not instrumentation grade, so I don't want to vouch for its 100% accuracy, but it has that. It's really neat the way it lets you measure the impedance, which is basically resistance to AC, and you can actually see how your hot lead in your outlet is doing, and your neutral lead, and even the ground lead. These things have different loads on them, and they may have different terminations, and the impedance may vary. I just chose to use the hot lead because that's the power source on this thing. So this is my AC mains, and my AC mains goes from outlet to a power strip, and then through a piece of wire to this guy. And so all those wires are included in this measurement. So the actual impedance right at the source is probably a lot lower than this. Every time you have an outlet, this number degrades because you have contacts that are loose and wires all add impedances, so forth. So anyway, I get 0.26. I then plugged in into PS Audio P12, and shockingly, it's 10 times worse, more than 10 times worse, 11 times worse. And I'm like, whoa, this must be a mistake. I plug it, unplug it, and go back and repeat, and yeah, it's 3 ohm. And if it's 3 ohm, then that would explain the power losses, because that's a lot of impedance to have inside the box as you pull current. That impedance times the current becomes a power loss inside the P12. So it explained that. The problem was that, as I said, I didn't have high confidence in this meter because I had never used it for this kind of analysis. And so I put a caveat in here in bold saying, look, I can't swear to this analysis here being correct, but directionally the two are supporting each other. One says that, hey, you've got power loss, and when you have high current amplifier running, and by the way, your impedance is high, so that explains the losses, as losses are inside the P12. But of course, folks say, well, that's impossible. Then, how could it be that companies advertising this ridiculously low, impedance? So surely your measurements are wrong. And that was the response of the company initially, just like, oh, Amir's too young, he's still learning what he's doing, and he'll figure it out. But he probably doesn't know what he's doing. We know what we're doing, and his stuff must be wrong. Well, that resulted in 23 pages, well, now it's 25 pages over here of arguments, and people internally on the forum arguing with me. People think it's a walk in the park, just post these results, and everybody in the forum agrees with me. They do not. They severely scrutinize what I have, and many people declare the test wrong, and with many technical challenges and so forth. But something good came out of it throughout all those arguments was that a member went and contacted PS Audio and said, hey, you say 0.008, Amir's measuring 3 ohm, what gives? And the support person went to Paul McGowan, who's the CEO of the company, and said, oh, Paul says that you probably used a high current port, and the high current port isn't as good as the rest of the ports. Well, let me first tell you what that is about. If you go to the original review I have in here, I don't know if you can see it well, but there are 4 sets of outlets in here in pairs for each one. There's a zone A, B, C, and D. Almost all the tests that I did in the original review was done with zone A. I was testing either with no load on the unit, or I was testing it with a headphone amplifier or different power supplies. They were all low loads, and I know from experience to not use the high current ones because sometimes they're degraded for whatever reason. And so I had done all those testing with zone A. But when I went to test an amplifier, naturally I'm going to use what the equipment's labeled as high current. It is an amplifier is high current. I wasn't about to stick it in the low current ports and damage the unit or have them come back and say, of course you were supposed to use the high current port, use the low current port. And if you look at the manual, find the manual, you can see that it says that bear in mind that the P12 will output the same voltage across all the zones. So to me, that means it's regenerated and it's proper. So, you know, I looked and there's nothing in there about something being wrong with that port or that port having higher impedance. Well, Paul McGowan went and I don't know if I have that post of his in here. Anyway, he goes out, you can go to their forum and read it. I'm going to get to this punchline. But he basically says, oh, that port, it's just a pass-through port. It's just got some filtering on it. It's not regenerated. Well, that's clearly wrong because by then I had tested zone D, the high current one, and I knew A was regenerated, and I'll show you why I know it was regenerated with this first test in here. I had measured zone A and zone D in my original review, and as you can see, their performance is the same. All the distortion has been removed, so it absolutely is regenerated, and what Paul said was flat out wrong. More importantly, I have a variable output transformer, and I plugged it in, and I tested zone D, and I could adjust the voltage from 90 to 130 volts, and as I adjusted it, it stayed on 120 output. So for sure, Paul's statement was wrong. But anyway, it doesn't matter. He's claiming that port shouldn't be, you know, isn't the one you're supposed to use. Okay, CEO of the company says I'm supposed to use something else. All right, let's measure another port. So I measured zone A this time with the same meter, and lo and behold, I'm getting numbers between 0.14 and 0.16, not 3 ohm. So clearly, the other zones have much lower impedance, not the ridiculous 0.008 that PS Audio claims. Again, that's, I'm sure, internal impedance, not across power cords and what have you in a live system. But anyway, this is much more reasonable. And indeed, when I repeat the test that I just showed you, we see now that the power deficiencies disappears. If you use zone A, you get identical amount of power, but you also get identical noise and distortion. So no improvement, but no loss either. So if you use zone A through C, presumably, they do this. And I ran a power test again, a peak and maximum, and there's still a tiny amount of power loss, but that could be because my raw AC is slightly higher voltage than it and allowed the amp to run a little bit hotter or produce a little bit of output. This is not an issue. This is understood. So we now verified that the zone D has an issue on it, and the question is, what is that issue? Paul McGowan is basically feeding us misinformation there. He doesn't know. I don't think he's doing it on purpose. By the way, I think he just didn't know. He didn't design the equipment, and whoever designed it correctly had it documented, as I showed you in the manual, that that port is regenerated. But what is going on with that port? So the people who own older versions of PowerPlant, they say that in their documentation says that the high current ports have a limiter in them. What is a limiter? It's an Inrush limiter, meaning that when you first plug into something, it tries to lower the voltage and lower the demand on the power plant. Because if you don't do that, you can exceed the current capabilities of P12, and either it'll go into protection, blow a fuse, or damage it. So from their experience, I'm sure, or whatever, they realize people, when you tell people you can plug in powerful devices into a regenerator, you better, you know, I shouldn't say you better, they put an Inrush limiter in there. The problem with an Inrush limiter is that it is now going to sap all the dynamic power that you were trying to claim that the equipment provides, as I showed you in my testing. The Inrush limiter, they later on post, the design engineer or one of the engineers finally chimes in and says, oh, yeah, we have a thermistor in there in line with zone D. And the thermistor has to get warm before it reduces its impedance. And they assume that that resistor will always get warm and run that way. Well, no, that's not the case. The only way that resistor can get warm is that if you pull max power out of the P12 continuously. Music doesn't work that way. You listen to music, average power may be 1 to 5 watts, and then a peak comes, and that peak may be 100 watts, 200 watts. So there's not enough quiescent current going through the P12 power plant to heat up that thermistor and basically remove its inrush limiting. And so it's a completely opposite design to what you want to claim, that this thing improves the dynamics of an amplifier. Well, it doesn't, because if it's dynamic means peak to the average is big ratio, and your inline emitter, as my testing shows, is limiting power. The proof, again, is right at the beginning. I measured it, and, we're losing power. We're losing 7.5% power in a real amplifier with real tests. So you can't say, well, that's just theory, but in practice it works. No, it doesn't work. And at any rate, this should have been in the specification, saying that the zone D can have a high impedance up to 3 ohm, or about 20 times more than your outlet, and don't use it. Now you might say, okay, well, I'll go use the zone A. My problem with zone A, or the other low current one, is they put an inrush limiter for a reason. And that reason may have been to protect the power plant. And I don't know if it's safe to pound on the low current ports without that limiter. Is that going to damage the unit? Is the voltage going to sag and cause problems for downstream devices, surges? There's a feedback mechanism in the power plant. It's just like any other amplifier. What does it do to that? It's a big mess. As a minimum, I expect the company to go and clean up the documentation, clean up the specification, explain all this stuff to people, because it impacts how you use the device. Every consumer up to this point, I'm sure, assumed that those ports are all good, and they plugged in their power amplifiers to the high current port. That's what it says it's for. And the manual confirmed that they're just as good as the rest of them. But now we realize it isn't as good as the rest of the zones, and you better, you're forced to use the other ports, and it doesn't make sense. Very unfortunate is the tone of language from the company. And this is Paul McGowan on their own forum. Goes out when he first claimed that the power strip, that the zone D high current is just a power strip, just got a little filtering and it's not regenerated. He comes out and says the responsible thing to do is for me to revise the review and give him an apology. Really? I'm measuring a real amplifier plugged into your device per instructions, per manual, and it's showing power loss. I measured impedance, doesn't match your spec. You have not shown one measurement, one piece of data saying why what I did was wrong. I did what every user would do, plug in their amplifier into the high current port, and the information and analysis I'm getting does not jive with what you're explaining, and clearly you're wrong, because I showed you that that zone D is regenerated, unlike what Paul was saying. So the mistake was his, not mine. Well, good news, if you can call it, is that this morning he finally finds out that he screwed up. Let me reduce it in size so that you can see that is Paul McGowan, CEO of PS Audio. He says, one thing I screwed up on, and that it does regenerate the output. Yeah, we figured this out. And how you figure things out like this? Measurements. Measurements have value. If they had done this kind of measurement and analysis like I did, plugged in a power amplifier and measured its peak power, they would have noticed that it's producing less peak power, and they would have either revised the design or documented or something. And, it just says it casually as if it's still my fault or something that this is the case. No, it's not good thing to just screw up after 2 weeks that I've been testing this device, to come back and at the end say, I just screwed up. Like, no, if you didn't know how the box worked, don't talk about it. Yes, a CEO of company can't remember all these details. Forgive him for that. What I can't forgive him for that is that he goes out and says, oh, this Amir guy doesn't know what he's doing. He should retract and post an apology. That's not the way the world turns if you want to have a good relationship with customers and potential customers in the future. I've done extensive testing of this box every which way, and they haven't lifted one finger to produce one measurement to counter everything that I've shown you. But yet the statements are all this condescending things. You're still learning. One day it'll be good. But, these guys all just always want to say stuff doesn't work. Hey, I love to say it works. I like the look of the machine. Hey, if it improves fidelity, look, I'm going to get behind it. I don't care what it costs. $5,000, $6,000 is nothing if it improves fidelity. The problem is it doesn't improve fidelity. I've tested it every which way. How do you argue with this graph? You want to tell me your noise floor went down? How did the noise floor go down? Because the instrument is trivial to measure noise. It's trivial to measure distortion. It didn't change at all. It's not like a tube amp where it added euphonic distortion or something you could argue. It didn't do anything to the output of the amplifier. It's the thing we listen to. It's the thing we hook up to our speakers. It is not changing one hair. It's not like it deviated a little bit higher. We could argue over the difference. Nothing. And importantly, the company hasn't countered any of these measurements. They make a bunch of amplifiers. They make a bunch of these power plants. They have an industrial AC that you could argue in their facility could be dirty. Hook it up. Show some analysis. Show that you know how to measure these things. Show that you understand this level of instrumentation analysis. Don't just throw around, ridiculous impedance numbers and just tell a story. And unfortunately, that's how this high-end audio world is working. You give a plausible story, and people who are not engineers believe this stuff. I guarantee you I can line 1,000 engineers out there, design engineers, proper design engineers, and every one of them will just roll their eyes if you say you're going to regenerate AC to improve the performance of an audio device that operates on DC. The DC equipment doesn't care what the incoming AC waveform looks like. First thing it's going to do is smash it into a DC and generates its own noises that you have to filter and worry about. But it is not like we take that 60 hertz and modulate it to play music. The 60 hertz we want to get rid of right away, and that's what your audio equipment does. So it's not a surprise that it doesn't do anything. If you watch one of Paul's videos on motivation for why he got into this business, was that he thought when you use a power conditioner or filters or power cords, they reduce noise or something, he said, but the sound is not as real anymore. And it became real when he built the first one of these things, or his company did. Well, that's not proper motivation to go build something. You measure it first. So, okay, is there a difference with those power conditioners? If you had measured those like I have, you would have noticed that nothing had changed anyway with those power conditioners or power cables. So then you should have been prompted to go do a blind test when he didn't know if those things were being used or not, and see if the results are reliable. And without verification of measurements, he just jumps in and creates a solution for a problem that just doesn't exist. Not just because I'm saying this, because it's just the way the design works, electronics works. In the other review, I showed you how the output of a power supply, DC or switching, doesn't care one bit about what you do there. So anyway, we could have our blood pressure go up, talking about high-end audio and how broken it is, and how company after company just chases expensive solutions because audiophiles latch onto these pseudo-technical stories and believe them. But hopefully, at least some of you step back and say, wait a second, the optics of this is not right either. There's the CEO of the company who's been saying I should retract my review. Then he comes back and says, oh gosh, I didn't realize I said the wrong thing. This thing does have an Inrush limiter. Right here, has a 3 ohm Inrush limiter. Exactly what I measured. So why did he say that measurement was wrong? The measurement was 100% correct. His original response, if he knew what he was talking about, was to say, hey, yeah, that's correct. The 3 ohm, it does have a 3 ohm limiter. You can't use it for power amps. And if he had said that, then his own customers would go back to him and say, whoa, I've got my power amp plugged into that board. What is it doing? And get a proper thing. Instead, we get flippant things. He says the manual doesn't say anything because it's not made for people who are going to measure it. Really? Come on. This is useful information for every customer to know that the high current port in this device reduces dynamic power, opposite of what the companies say. Anyway, let me get back to the rest of the testing I did. I also went and tested an amplifier that's Class D and uses a switching power supply. And here, even when using it on zone D, it makes no difference. I'm showing you the power difference in here. Again, raw AC produced just a hair more, but that's not consequential. Why doesn't it make a difference? Because a switching power supply is a power regenerator. That's exactly what it does. It takes AC, converts it to DC, converts it to a square wave AC, and then switches at very high frequency, not at 60 hertz that PowerPlant does. And because of very high frequency, the electromagnetic components get very small. That's why switching power supply are efficient and small, because they're doing it smartly. They're regenerating power in a smart manner. And when they regenerate the power, they could care less if you filter the original AC or not. The first thing they do is knock it down to DC and filter. So anything you have that's switching, it's just silliness to plug in this monster in front of it when it's already regenerating its own power. So the moment you see a switching power supply adapter that's external or internal, or if you have a Class D amplifier, none of those devices by definition care or want. And again, even linear ones don't care. But anyway, here I actually used the high impedance zone D, and it didn't care still, because that impedance didn't matter. It regenerated its own power. So where are we on this thing? The bottom line is simple. In every test that I've run, either it does nothing useful, or if you use the wrong outlet, zone D, with high power devices, you lose power. The net is either the same or you lose something. Not one test has been produced by the company or any other outfit, any other reviewer, that counters what I've just shown you. I believe Stereophile tested the P12, but unlike their norm, did not measure it. Why not? Measure it. That's, that magazine normally measures things. Why didn't they measure it? Maybe they didn't know how to measure it. I couldn't fault them. You do need specialized instrumentation to measure the AC line, but they could have hooked up an amplifier, measured its power before and after, instead of just accepting the word of the company. So bottom line is very simple. Extensive analysis across 2 to 3 weeks. Everything people said, it could do this, it could do that. It's just the conclusions are solid as a rock, and the company hasn't produced one measurement to counter any of it. All they do is say, who knows? They don't know what they're doing. Anyway, we've shown that we do know what we're doing. We figured out what the device does before Paul McGowan did. The other thing was that just repeatedly gets said in these reviews, well, he just measures and doesn't listen. And if a reviewer doesn't listen, it doesn't matter. I mean, you got to be crazy. If I say, here's a glass of water, I pour from a filtered water in one glass, and I pour the same thing in the second glass. Are you really going to do a taste test between those two when you know that the same bottle was used to put water in both glasses is identical? What's the point of doing that test? You know in advance that there can't be any difference. I'm not sitting here wasting my time looking for detailed differences that I know does not exist. There's nothing being impacted on the output of the audio devices as measured. Remember that the advertising for this company, and many like them, only talks about what it does to the AC. It never, ever talks about what it does to the output of your audio devices. There's no measurements or anything. They just imply that there is improvements there. Anyway, I could argue these points to death, or I could just do the bloody test. So fine. I set up 2 tests, one a headphone test and the other one speaker test. One of the reviews PS Audio Post was with headphone testing review, and the other one was, I think, with speakers. So I did both. It was a very resolving, as they call, expensive chain. It was a $1,000 RME ADI2 DAC, driving a topping A90, which I think is $600-700. And then the output of that drove this Dan Clark Stealth headphone. It's a It's my everyday headphone. It's a closed back. It is $4,000, a lot of money. So proving that we're not cheap and performance is good. I bought this because I wanted to keep it after I got the review sample. And this is superb. It has the lowest distortion I've ever measured on a headphone. And being closed back means it isolates outside noise, so I can hear if there's noise difference between devices that I'm testing. And certainly this is a higher end chain than just about anything any reviewer has on this thing. So about a $6,000 chain I'm using, and that's not including the sources and so forth. Funny thing is, the moment I started listening to the raw AC first, just plug into my power strip, and then I moved the plug into the P12, and immediately I thought the P12 sounded better. Exactly what everybody's impression is. It's like a shock to my system, like, whoa, it got better. I've explained why these things happen before, because as soon as I plugged it in, I started to pay attention to what the difference was, and immediately you have a different impression than when you casually listening. And so I unplugged it, plugged it back to AC mains, and I was like, oh, wait a second, same improvements are there too, as I listened carefully. And I did that 3 or 4 times, and then by then they just sounded the same. So definitely not conclusive that there's any difference whatsoever. But I heard a difference. So to people who say he measured first, therefore he was inclined to not hear a difference, I'm being frank with you. I did hear a difference. It just wasn't a real difference, and it faded away. For speaker testing, I use my regular 2-channel system. It's a pretty high-end system. I don't usually talk about it because I don't want to brag about stuff like this. I know there are some voyeurs out there who just buy stereo equipment so they can say how expensive their stuff is. But in this case, I had to brag about how expensive it is because somehow people think I only want to look for cheap stuff that does well. No, I pay a ton of money to have things that are nice to look at and, of course, perform well. So this is my system, and the testing that I did was with this Mark Levinson 532 reference amplifier. It's discontinued, but I think when it was new, it was $20,000. It's about a 120-pound stereo amplifier. I think it's rated at 400 watts into 8 ohm and 800 watts a channel into 4 ohm. So amazing beast as far as power. It drives 2 Revell Salon 2s. The Revells, I think they retail for $23,000. So combined, that's about $43,000. I have a $2,000 Matrix audio streamer and DAC in here and a silent PC I built for streaming. And hosting my room core on it. And so overall, we're talking about a $50,000 system. It's incredibly good sounding. Every day I wake up, kiss the ground that I could afford to put together a system like this. It just puts a smile on my face. Anyway, you can't argue that I try to use a $500, thing or, hooked up an iPhone with earphones and try to test. And I listened to this system. Let me see if I find my review again. And ironically, I started with AC feed. And to make things really bad, I actually took a little thin power strip, those are cheapy $5 ones, and powered the amplifier using that. So to exaggerate, really bad power. And then I unplugged the amplifier from that thin power supply, plugged it into PS Audio P12, which was being powered by that thick Pangea cord. An immediate impression I had was actually lower fidelity this time. Not the same, but lower fidelity. I thought it sounded more compressed and congested. But of course, that was also just random impression. I plugged back into the thin power strip, and it sounded the same. And I went back and forth a few times. It was the same. The test, of course, was all cited. You might say, why aren't you doing blind tests? Blind test of what? There's nothing here to test, to know. But every claim was made that, proper reviewer tests by listening. No proper reviewer they're pointing to is using blind testing. So if you want me to be a proper reviewer, do testing just like you do and just like they do, I did. And I reported my observations frankly, and I actually said there were differences, but they vanished. Differences for good and differences for bad. So if this is what you wanted, you got it now. This is why I don't post them, because it doesn't have any value. It is not a proper test for somebody to just stick something in there and say, whoa, the sound improved, and wax poetically about how the mids did this and the veil was removed. It's just silliness, you know, on this thing. So bringing us to a close, I really wish that PS Audio would go back to the beginning, run these tests themselves. They don't have to tell us anything. They could just run it internally, you know, and say, are we really selling people stuff that doesn't work or actually degrades their stuff? With people like me who got nothing else to do in life than sit there and make YouTube videos and test our products with expensive gear, maybe the gig is up, and we don't want to suffer like this in the future. Let's make money from stuff that works and performs, and not stuff like this that just, you know, they make technical claims. If this thing just made some superfluous comments, it'd be one thing, but they pretended there are technical reasons why this device works better, but those technical reasons don't pass muster. They violate engineering design principles of how equipment works. Please, Paul McGowan, if you care about the future of your company, get on the straight path, produce products that people care, low noise, low distortion, high power, high fidelity, transparency. If you want to build non-transparent stuff, cool. Make it clearly known that the stuff's non-transparent. Don't claim that they're better unless you have some controlled blind testing that shows they're better. They've got the system and equipment in place to do proper testing, but of course they're not. So, you know, I'm trying to be as generous as I can with my comments, given the, you know, really amazing hostility that's come back from the company only posting in their own forum. During this entire time, they haven't contacted me once. They could contact me. I don't bite. I'd love to hear from companies. Plenty of companies whose products I review that don't perform, by the way, they contact me. You know, some unhappy, some appreciate it. Some say, okay, in the next version, we're going to do X, Y, and Z. Thank you for doing the testing. Or how did you do this test? Can we have the test files for Audio Precision? Sure, here we go. What can I do to help? If you have the next generation products, you want me to test them like this for you, happy to do it. I'm here as a service. There's all this talk about I do all this stuff for views and things. There's no advertising on my forum. There's no advertising on this video. I am fortunate enough to not need to make money off of this online venture. And members are kind enough to donate, but, you know, the view counts and things like that don't matter because there's no ads, there's no nothing in there at all. So I'm doing my best to, you know, to do a service for owners. The owner of this product cared how it measured. So, you know, a company needs to pay attention that, you know, customers do care. It's not that, you know, nobody cares and could just dismiss me out of hand. And I'm hoping other people start measuring properly too. And, you know, we get confidence around what claims there are and what reality is. Anyway, the device is now packed. And this morning FedEx picked it up, so I can't do any more measurements of it. If PS Audio comes back with a fifth answer now on all of this stuff, I hope they provide measurements to replicate my results and drive the conversation that way. I don't have one. I do have a P300 from PS Audio about 30 years ago, and I don't ever use it. It's sitting in the back. I have my AC generator that's far cleaner than PowerPlant. I don't use it. So it's not like I can't own these things. I own them already. If they did something good, I'd use them. I'd use them in my measurement rig. I don't use them anywhere here because they don't do anything. I use my same dirty power to measure equipment that produces state-of-the-art in noise and distortion. So clearly, dirty power is fine. So how often do you hear that? Alrighty, thanks for watching this long video, and I'm sorry I'm boring you with yet another video on this topic. Okay, see you in the future, hopefully on a different topic than this one. Bye-bye.